Okay, so we did get started a little bit late today. I kind of apologize. We've had some issues with a dog here, so going to be kind of a shorter lecture, and I'll probably try to get kind of a lecture recorded, maybe at the end of this week or early next week, where I do some review problems as well. So this is kind of new material. I'm just talking through some newer papers that have been put out there, and then I'm also going to do a little bit of Excel work that hopefully this kind of discussion is all helping you kind of with your projects. All the data, I think I've got every single person in the data set that has responded to my emails about if they didn't maybe submit a proposal. So if you haven't gotten a data set, you need to email me because unless something didn't get sent in an email, I have it checked off that I've sent a data set to every single person now. So, first paper I wanted to talk about is kind of going back to some of the discrimination that we had talked about. So this is a newer paper, I think it was 2019, on evidence of racial discrimination in MBA wages. So if you're thinking about kind of wages, we have some measure of salary. So taking a natural log, we're not going to kind of go into what that does for us. We'll kind of just keep treating this as though this is just a salary variable. But the interpretation would be a little bit different since we're taking the natural log, but I won't expect you guys to know that. So really what we're thinking about is how is this y, or this dependent variable, impacted by everything else on the right-hand side. So the main one we're going to focus on is race, right? Is there, if the player is black or kind of non-white, does that have a negative impact on salary, right? Is that coefficient beta 3, is that negative, right? Holding constant, the player's performance, the population of the city, the winning percentage of the team, all these other things, right? So here's kind of the regression output. It's a little bit small, so what I'm going to do here, I've got the tables posted so you can kind of tell what tables they are. But I'm going to pull up the actual paper because I can zoom in on a PDF. So, there we go. My computer cooperates here. Okay, so that's a little bit easier to see here. And you go back to, where is it? Table 3. Yep, there we go. So here's our regression analysis. And kind of 4 different models, somewhere certain control variables are included, somewhere it's not. And let me see if I can get this so that it's... Okay. I want my cursor to come back. For some reason, it's not. This is annoying. Well, what in the world is going on here? This is annoying as can be. There we go. Wait, is that it? No. I'm gonna lose my mind. What in the world is happening here? Okay, well, we got to kind of have this back. So anyways, here's our regression analysis. Sorry for that. And we've got the controlled age, whether or not the contract was a multi-year, foreign-born, college, restricted free age, all these control variables. And the main one we're going to focus on is if the player is black, does this have a negative or positive impact on that player's salary? So 1 if the player is black, 0 if not. We look at all of these, and no matter what model, no matter what controls we have added in there, even probably the preferred one, which is this last column 4, it looks like there's a negative impact, right? If a player is black, holding constant all this other stuff, all these other control variables, if the player is black, the expected salary would be 0.13 lower, or kind of the interpretation there is really 13%. And that's because of that natural log, so we don't have to worry too much about it. For anything I would give you, we would just keep salary kind of at that base level, like in the millions. But here we see this negative impact coming from being black, right? Even with all these other control variables, right? So on top of that, go to the next table I wanted to show you, which is table 5, right? So it could be that not only is there this kind of racial discrimination going on for player salaries or player wages, but potentially that varies depending on like what skill level or what level of salary that player's at. So you can kind of imagine maybe at the highest level, right, higher paid players, maybe race isn't a component, right? If the player is good enough, there's no kind of discrimination that kind of leads to lower salaries, because if there's a team willing to pay, who's not discriminating, willing to pay a little bit higher, well, then that superstar player would have went to that team. And so discrimination is really costly when it comes to high quality players, but maybe not so with low quality because there's a larger supply of them, right? There's only one LeBron James, but there's a ton of bench players, right? And so if we break this down into kind of these different categories for individuals in the 90th percentile or above in salary, and we look at kind of that guy left there, well, actually we see kind of the reverse is true. That at the highest end is actually where most of the discrimination is occurring, right? And so it may be, there's something going on where those higher paid players, whether or not it's bargaining with their, through their agents, but there is some type of discrimination going on in that there's a lower wage from being black at these higher levels of income. Sorry, I said income, higher levels of salary. Statistically, not significantly different from zero if we look at the lower kind of distribution of salary. Right? So it's kind of interesting, probably not what we maybe would necessarily expect. If we do a similar thing, it looks like, except for we interact whether or not the player is black with the white population percent in the city, what this is going to do is going to tell us, okay, look, here's the effect if a player is black, right? Here's nothing statistically different from zero, and so we said there's actually no wage penalty. But where is that wage penalty coming in from that we were finding before? Well, now that we've included an interaction term, when the player is black and the percent of the population in that metro area that the player is playing in is white, that's what's leading to this decrease in their salary. So it's at these kind of high levels of income or high levels of salary, the upper end of the distribution, those players, those high quality players, if they're black, they're being penalized when they're playing in cities that have a higher white population, right? Or at least that's what it appears to be from these results. So kind of interesting newer results. Like I said, these papers probably not going to have a weekly reading this week. In terms of, I'm going to walk through these three papers, but I might ask you questions on any of them since they're in the recorded lecture, right? So I probably won't put them up as weekly readings. You don't need to necessarily have to read any of them, but anything that I mentioned in this recording, I could ask you a question on. Okay? So this is, kind of some interesting results, some interesting findings. So the next one that we're going to talk about is then not racial discrimination, but whether or not there's gender differences going on, right? So sometimes when we talk about gender, is not just discrimination. This one isn't necessarily looking at discrimination, but it's trying to say, well, look, if we see differences in wages in sports for men and women, can any of this at all be driven by any differences in their behaviors to different environments, right? So we've talked about with the little kids, when they ran races against each other, there's differences in their times, depending if they ran against other little kids, and also if they ran against other little kids who were, the same gender as them. And so what this paper is going to do is to say, well, okay, look, are there differences when we have cross-gender matches? Do men and women just respond differently to those? So if we did have environments in which we actually, we didn't have separate leagues, so we actually had a league where we could say, okay, are men pay different or more than women? That's going to be a problem if, when competing against each other, leads to different responses from men when they go up against a woman and when women go up against men. So what we're going to do is we're going to control for, so this paper actually looks at 15 we'll pull it up. I forget the exact name of what this sport is. German 9-pin bowling, right? So some type of bowling. And they explain in the paper kind of the process, like either you get 50 or 30 throws, and there's 5 rounds, and you got to knock over all the pin. That part isn't necessarily that important. What is important is we know we have a game in which we can measure how well someone is doing. The other cool thing about this was they have a ton of observations, right? 500,000. and the leagues are mixed gender. So this isn't a professional league, so it's not like there's a ton of money on the line here. But the kind of nice thing about not having a ton of money on, we can see, well, are there differences in kind of innate responses to cross-gender competition? So this Y variable, they have a couple different measures since there's different rounds. This is like the number of points, or basically the number of pins you knock over. So you can think of Y as your measure of sports performance. Now there may be differences in male and female. So if on average males are larger, and maybe that either hinders them or helps them in this 9-pin bowling, we want to account for that. So we control for whether or not someone's male or female. But then here's the one where it's going to allow us to see, is there some impact on performance when a player goes up against the opposite gender, and then interacting those two, this third variable, which is female variable times am I up against someone of the opposite gender. Well, these are both ones, so this coefficient tells us the effect of when this goes from 0 to 1, it would have to be going from a male who's going up against, sorry, let's say that again. This impact would be if we had a female who's going up against someone of the opposite gender, so going up against a male, here's the additional change in performance, relative to just a male going up against someone of the opposite gender. Right? So we've got kind of this additional impact. So this will tell us how kind of the baseline effect of going up against someone of the opposite gender for both males and females, and here's the additional effect that would come from going up against someone of the opposite gender for females. And then he controls for like previous ability, a bunch of other different demographics, right? So once again, these are kind of small, so I'll just go to the paper so we can see this a little bit better. So let's scroll down here. Table. I'm getting close. Here it is. So these F scores, I think it was something like the number of pins that they had missed or left up, but you can kind of think about score points as the ones we'll focus on. So notice, if you look at kind of this control for female, when we look at kind of not controlling for the differences in ability of their opponent, it looks like maybe being female and going up against a male has kind of a negative impact. But the thing that this paper kind of mentions is, well, if there's just innate differences in male and female play, then because I'm going up against someone of the opposite gender, if I'm female, that inherently means it's someone who's male. And so if males on average have a higher ability, I need to control for that ability. So these columns does not control for the opponent's ability. These columns do. Right? Oh. Deselect all. Okay. Man, this thing is really getting on my nerves. Okay, there we go. So in the preferred column where I control for opponent's ability, now it looks like the interaction term, it is still negative on points, right? It's still negative, but it's not statistically significant. In fact, it's not really that close to being statistically significant. And on their kind of overall score, it's even more so not statistically significant. So any kind of differences in behavior that we thought we saw was really just based off of the differences in the underlying ability of male and female in this 9-pin bowling. So this is kind of evidence that maybe there's really not any differences between males and females in terms of when they go up and do some cross-gender play. So now if we had a sport where we had wages being paid, we control for the ability of the individuals, we could actually probably get an estimate of whether or not there was gender discrimination going on. So this is kind of a nice support for that. I don't think there's any other table I wanted to mention on this paper. Let's double check. Yeah, I only put one here in the slides. So I thought this was kind of an interesting paper looking at gender discrimination, not necessarily discrimination, but thinking about issues of gender in sport, and if we were to try to estimate gender discrimination, what we would need to also make sure is we control for these previous kind of not only the ability of the individual, but the opponent's ability as well. Okay, so the next paper I also thought was pretty interesting, which was whether or not we can identify consumer discrimination from social media followings. So what this paper did was they went out, and I think it was from Major League Baseball, and they got some measures of the, well, I believe it was Twitter. Here we go. So if we go up here as a table. I forget exactly what they did. I thought they gave a sample of the Chicago Cubs, actually. Oh, yeah, here it is. So they gave the followers on. Oh, no, I can't remember. Twitter. There we go. Twitter accounts. So they've got, like, here's a sample, right? The Chicago Cubs. We, determine what race each player was. We've got their age, number of games they played, their experience, their position, and then how many followers they had on Twitter. Which, poor Matt Scherzer here, right? So we've got all these Twitter followers, and they built this for every single team across a bunch of different years and said, okay, well, look, what we're going to do is we're going to run the regression and say, are the number of followers that someone has impacted by whether or not they're Hispanic, Asian, African American, or kind of white? And then kind of the group left out there would be kind of, I guess, other, right? Any other race. So if there's negative coefficients on any of these, then that racial group is experiencing kind of negative, potentially negative consumer discrimination, right? We're getting a measure of whether or not consumers are kind of exhibiting racial or racist, I guess, tendencies in their social media behaviors. Controlling for the age, the experience, whether or not they were an all-star, the win percentage of the team that they're on, position, games, a measure of how good the player was. So for hitting, this included things like, slugging percentage, and then for pitching, things like ERA. So we're controlling for the quality of the player as well. We're controlling for what year it's in. I'm guessing over time, right? Twitter followers have just continued to increase. So we've got all these things, and they're also another important thing. They're also controlling for the population of different races in the town or in the city that the person plays in, the metro area. So that was a good control, I think, that they added in that I thought was pretty clever. They also controlled for how many followers everyone else on the team had. You can imagine maybe if there could be some players on a team that's more popular, they're going to end up with more followers. And so after controlling for everything, we get our regression results, right? So they control for they have a couple different measures of hitter quality here that they try out. I don't know why they didn't just kind of simply include several statistics in here, but they ran them as 3 separate models, so that's what they did. But really here we've got our 1, 2, 3, here's our 3 kind of race identifiers. They must have, it looked like here they dropped out the group white so that everything should be relative to a white player, right? So the interpretation of my coefficient now on say African American is if a player is African American relative to being white, we would expect their Twitter followers to be about 16,000 lower. Now, our standard error here, and we don't have any stars, so standard error is pretty large. It's not statistically any different from 0, but that's how we would interpret just the coefficient. Now here, the one interesting thing is, for Hispanic players, they are, if we look at this kind of row here, 1, 2, 3, they're all significant at the 1 star is the 90% significance level. And so we can say that it looks like it's about 35,000 fewer Twitter followers for a player if they're Hispanic relative to a white player, holding constant all these other things in the regression, right? So it's pretty wild. It's like if we had 2 players of the same age, same experience, same number of years being an all-star, on a team with the same win percentage, they both play the same position, the population of the city they play in is the same, everything's the same except one of them's Hispanic, one of them's white. We would expect the Hispanic players to make about 35,000. Sorry, not make 35. Have 35,000 fewer Twitter followers. There we go. So pretty consistent evidence, and these were for only batters because we had the performance measures were for batters. But the same thing for pitchers. It actually ends up. So we look at Hispanic, negative, 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 and now they're significant at the 2 stars, so 95% level. So pitchers and batters get fewer Twitter followers if they're Hispanic, and so there's some consumer discrimination going on against Hispanic players, it looks like. Now, the one interesting thing here is And I'm guessing this has something to do with just there being a large market outside of the U.S. that may be more drawn to players like of their same race. And so when you look at Asian pitchers, right, huge number of Twitter followers, 500,000 more than a white player or a white pitcher. Like I said, I have a sneaking suspicion this has something to do with the international markets that we're really not capturing here at all. Um, but that is interesting that there's kind of this huge increase in Twitter followers for Asian players, holding constant everything else. Right? And I said players here, it's actually just pitchers. That didn't really pan out when we look at the results up here for batters. Right? So some interesting findings, but the one thing that I was a little surprised is, at least in Major League Baseball, it looks like there's no statistically significant effect on at least the Twitter followers for African American pitchers or batters. In fact, the sign is positive for being African American for pitchers, although the standard error is large. We don't have any statistical significance there. So it's kind of another interesting paper. It helps identify there might be some consumer discrimination going on, and so all the things we talked about with consumer discrimination driving there to be maybe potentially lower wages for that particular group of players. Maybe if we look at wages in Major League Baseball, we would expect that Hispanic players maybe are being paid a little bit less, even given the same quality. Okay. So that's just kind of talking through 3 more papers. We got, looking at more regression output. So on the final, I might give you a table or something where you have to interpret a coefficient, or you have to say whether or not statistically significant, or if it's different from 0. And so just some more practice with that. Now, let's see. The other thing I had pulled up that I wanted to look at. Okay, so this is kind of might seem like a goofy kind of data set to some of you. I'll zoom in on it a little bit here. But I'm going to try to walk through how I would approach, and a lot of you I gave you data that's not even this raw, but I'm going to try to give you a little bit of an idea about how you maybe quote unquote clean up a data set a little bit so that you can run a regression in Excel. So I have this data set which is all this powerlifting meet data, and I'll put this up on Canvas so you can play around with it a little bit. I was kind of interested in this for a while. So, and actually, let's see. So once again, so what I would always start out doing, I've got my raw data, Control Shift or Command Shift on a Mac, over, down, select all the data, go to filter it, just to kind of investigate the data a little bit. So here I've got male and female, so that's a kind of variable I might be able to use. I've got the name, I've got age, all this different stuff. I've got the amount that they've lifted in different lifts. I've got the total amount that they lifted. I've got what their weight class was. So this is interesting, right? Now, what I'm going to do first is I'm just going to simplify this data. I'm going to go to this Wilks score and then only select that data. So, I should probably do it this way. I'll go to Wilks just to make this a little bit easier to deal with. And so I always don't want to delete the original data, so I'm just going to copy and paste this on a different sheet. Right? I'm then going to filter that. So that's how I always start to move data around. From there, I would say, well, look, maybe I want to know what's the impact of gender on total weight lifted. Right? And so now I'm thinking, okay, I need this total weight lifted. I'm going to keep the Wilks score. So this Wilks score is something that factors in body weight. So I want to keep this just to show you something later. So I'm not going to look at placing. I'm maybe just not interested in that. I don't need each individual lift, so I'm going to get rid of those. I've got this total kilograms lifted, so I do want this, but the problem is I see some blanks in here, right? So sometimes the data comes in, maybe for whatever reason, we just don't have observation, or that observation doesn't have a value there. So I'm going to deselect, so select all, I'm going to hit that check mark so it unselects it, or deselects, I don't think that's a word. We'll then click the blanks, hit OK. So all these blanks I want to get rid of because I can't run a regression in Excel with blank values. So I'm just going to go to the very first one, hit Control Shift, select these, and then hit the down arrow. Whoops, I hit twice. So hit my down arrow. So I now want to delete all of these observations. So I go here, and delete them. Get out of here. Okay. Now I don't select the kind of labels. I only select the observations. Oh, I forgot. So I have a pretty large data set here. So when I delete these, it's probably not going to be very happy. I thought I selected the even smaller, right? Smaller powerlifting data. So it might take. There we go. Took a hot second, but we got it. Okay. So then we'll go to select all again, and now all my data is back here. So now I've got that. Well, I need to know. I might want to control for body weight. So we got some blanks there too. I'm going to have to make sure I delete those. So I go up, hit select all, go down to the blanks, hit OK. Once again, select the first row, Control Shift or Command Shift on the Mac, hit the down arrow, right select, delete rows. So we'll have to wait a little bit. All right, that one didn't take as long, so that's cool. Hit OK. All right, so we've got all this in here, right? So what I'm going to do here, I wanted to say, what's the impact of gender? Well, the problem I have is sometimes we'll have these variables that come in that aren't numbers, but we could turn this into a number, right? So I'm going to put a gender variable over here. In fact, I'm going to say, just call it male. Okay. So equals if, and then this if statement, I will say, okay, if this cell, and I select that cell, is equal to, sorry, one equal to sign, and then in parentheses I put M, right, if it's equal to M, and anytime I'm looking for if it's a text is equal to something, I have to put quotation marks around it. Comma, if that's true, put a 1, comma, if it's not, put a 0, right? I then will double click, so if I go to the bottom of the cell, it gets this black big plus sign, I double click, double left click, it copies that down for every single observation, right? And see when it's female, we'll get a 0, okay? So notice when I added this column, it's no longer like in my filter, so I need to make sure that it is, so double click on filter to make sure it grabs that new variable that I've created. Okay. So now what I might be interested in, and let's make sure I don't have any blanks. Okay, cool. So I've got total kilograms lifted and whether or not the individual is kind of male or female. So maybe I go File, Options, or on a Mac, go to your tools. Then you'll see your add-ins. I've already added the analysis tool pack. If you haven't, hit go. Make sure you click it, hit OK. So now under our data tab, we've got data analysis up here. I then go click on data analysis, go down to regression, hit OK. So I want my Y variable to be total weight lifted. So I'll select that, Control Shift on a PC, Command Shift on a Mac. Hit the down arrow. My X variable I want is whether or not they're male. So I'll select that. And notice we'll hit OK. Looks like there's a pretty strong positive effect on total weight lifted from being male. I mean, the p-value is 0. So we could say with 99% confidence that there is a significant effect from being male on total weight lifted. Now, I guess that's interesting, but the problem is we probably already knew that. So the way I always kind of lead this decision is, well, if we don't control for some other things, it could be that this is going to be a really biased estimate. So what's probably true is there's not near as many 300-pound women in this data set as there are 300-pound men, and just larger individuals are probably going to be able to lift a little bit more weight. And so some other controls we might want to have, and really all I'm doing here is I have a sports performance, and I'm thinking about what helps me predict that. So I might want to control for weight class, right? What weight class is the person in? So I'm going to double check. I think the issue I'm going to have here is these pluses, Excel's not going to like. So I would probably actually have to take a little bit more time and kind of code these in differently. I wanted to do a real good job at this, but for the sake of this example, we're just going to say, I guess we're only getting results for people who are 145-pound weight class or lower, right? So, oh, I didn't want to do that here. Deselect all. I wasn't paying attention what I was doing. So if it's not a number, I can't use it in my regression, so I'm going to have to delete these observations. Like, I just can't use them. Right? So in practice, I would probably want to take a little bit more time and try to code those up differently, create some variables for what weight class they were in, were they in between certain weights. So this is going to take a little bit of time because it is a large data set, and I just deleted a large number of observations. So the data I sent you is really large and it has this problem where it starts kind of getting frozen. Let me know. I can send you a smaller version of the data set, although there's only one or two of you I would think I sent something that was too large for your computer to kind of have this issue where it'll stall out a bit. Okay, so we'll have to wait a little bit for this. So while we're waiting, so what I eventually want to do is my Y variable, I want to look at total weight lifted, and my X variable I'm interested in is whether or not they're male, but I want to control for body weight. So notice they're kind of all spread out all over the place. It's going to be a little bit of an issue when I go and try to run my regression, because for whatever reason in Excel, it needs all your X variables to be all in columns right next to each other. Right? So sometimes when the data comes in, I might have some things like I don't even need these variables, like the division or something that kind of separates my variables a bit that I'm really interested in. And that can be a problem because when we go to select what our X variables are in the data analysis tab, we can only select things that are right next to each other or kind of congruent. Okay? Man, I might have to just take a smaller portion of this. I was hoping to do something kind of neat with this, but looks like we've got maybe start out a little bit too big. It's working. So while we wait for this, the other thing I would mention, so I went through the main variables I'm interested in, but for your data sets, make sure you check you get rid of all your blanks, otherwise you'll get some errors. So we'll hit select all again now that we've got those weight classes out of there. So now I go to my data analysis tab, go to regression. The Y variable I want is total weight lifted, but notice what happens if I try to select multiple X variables. So I try to select, say, male, and then I hold control and select the weight class. Okay, I get this error term. It has to be contiguous reference. So basically what it needs is, it needs you to move these around. So I'm just going to select kind of up here, left click, move weight class next to male, and then I'm going to select these. Oops, these 4 columns, move them over one. So, oh my gosh. Move them over one, there we go. So now I've got the 2 variables I want as my right-hand side, or my X variables, or my independent variables, right next to each other. So now when I go to the data analysis, I hit OK on regression. My Y variable is this total weight lifted. So Control Shift or Command Shift on a Mac down arrow. My X variables should say the top, so I'll go all the way up to the top here. I want male and weight class. So Command Shift on a Mac or Control Shift on a PC and then the down arrow. I selected the labels, I selected the words at the top, hit OK. So now I've got my coefficients on 2 variables, right? So now the interpretation of this variable is going to be, this is the impact of being a male on total weight lifted, holding constant what the weight of the individual is. So it looks like there still is, oops, I didn't mean to go that, I meant to go to view real quick. So there still is a positive impact of being male on total weight lifted. But if we control for the weight class, notice it fell from 214 to 161. Right? So it's not near as large an effect. Right? Now, if we start to add in additional controls, we actually see that this probably starts to go away. But one thing that's a little more interesting is, okay, well, total weight lifted, yeah, these are larger individuals, men have testosterone, maybe that makes sense. But what about per body weight pound, right? Let's see if that is impacted by kind of male. So even if we just run a very simple regression, do data analysis, go to regression, let's instead, we'll do, what's the Wilks score? And then we'll do kind of whether or not they're male. Hit OK. We do have a kind of positive effect there, but it doesn't drive the Wilks score up near as much as it drove total pounds up, right? It's a much larger, or sorry, much smaller coefficient. And at this point I'm just playing around with regression. So another thing I might think about is, okay, yeah, but I could control for age. That would be cool. So I move age over here, so that's next to my other variables. And then, do I want weight class if I'm doing the Wilks? I think I'll do it. So we're looking within the same weight class. So go to data analysis, hit OK. I want to look at my Wilks score. So that kind of factors in weight and, but we'll leave in control for weight class. And we'll select all three of these now. So now I'm going to hit OK. Now it looks like being male still has an effect. On the Wilks score, you can kind of see age has a significant effect too. The older you get, the less weight you can move. So this is really how you just start running your regressions. Now, one thing that could be interesting, and also, if you're like, don't be dumb like me and label these so that you know where your raw data is at and where your other stuff is at. So if we go to this data that we kind of had deleted a few of the variables we didn't need, one thing we could also do is say, well, look, what is the impact of age on total weight lifted? But we want to do it separately. I want to do one regression for males, one regression for females. So the way I would suggest doing this is, so you select so you go over here, you've got the whole data set, go to the variable that you want to stratify or separate the data on. So let's go to only the males, right? And then I can Command Shift or Control Shift on a PC, select the entire data set after I filter it. I'll now hit, what do I want? So I'll hit Control C, so copy this and paste it over here. Okay. So I've now got only the males on this data sheet. And I can do the exact same thing, but only select the females. I can copy and paste this, and now I've got two different data sets where I could run regressions from to say, does the relationship between age and total weight lifted, is it different? If the coefficient is different from that regression than when I do it just on the database with females. Now the problem is, I believe, let's see if I'm wrong, I think this is correct. I don't use Excel to do a lot of regressions, so some of this I'm doing from memory of how it works. If I try to, let's say I try to do this, but I just filtered it, so I took the big data set, and I just filtered it by male, and I try to say, okay, what's the impact on total weight lifted of their age? So I do that, and I hit OK. So it runs this regression, it's negative 0.99. Okay, but notice, it should be the same if I run it from this data set where I copy and pasted only the males. So let's say I go ahead and I do this again. So I go total weight lifted, I go to age, I hit OK. Notice that value is not the same. So negative 0.02 was not the same as negative 0.99 because when I was running the regression off of the database where I had just filtered it, you don't really see it, but like, let me see if there's a big gap that I can see pretty obviously. So 36, 34. So what this does when you filter it is it just hides the rows. Well, I'll show you the easier way. So instead of doing this by let's say we do it by yeah, I can't believe that this isn't more. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, I got a better idea. Oh, alright, separate that out. Like, let's just say I select a couple of these. So if I look at this. Oh, God bless it. Why is it there? Well, my point was going to be, except for I can't find something that's good to separate this on so I can get a good evidence of, because there's just not a lot of females in this data set. But it hides those, it just hides those observations. So they're still there in the background, and so it's still using the entire data set when you run that regression. That's why you got that negative 0.99 with 37,000 observations, as opposed to negative 0.02, it was only 24,000, right? It was excluding all, that was the one where I just copy and pasted only the males. So the best way to run these regressions, if you want to do it for different subgroups, is copy and paste them onto different sheets. Filter it and then copy and paste it, and then run your regression with where you paste the data. Okay. So all this should be some helpful kind of if you're approaching your data set with a specific question. I think separating this off into two different things to compare the relationship. So notice here was, we'll rename it. So this was male, age, weight relationship. And we could do the same thing, but now on this one actually, since I already copied and pasted the male data, I'm going to actually just delete the male data here. Hopefully it doesn't get stuck for too long. And then I'm going to run a regression for female age, kind of weight lifted relationship, and show that when we have the coefficients, we could compare them, right? So if you want to have, your initial question was, maybe here the initial question could have been, how does age impact total weight lifted? And then after the initial question, separate that off into two groups, right? Kind of a sub-question. Does the relationship of age and weight lifted vary by gender? So that's where you split it up by subgroup, kind of run the regression for each one of those groups, and then compare the coefficients between the two. So let's see how much, hopefully it's not too much longer deleting these, but you kind of notice, I mean, I've got, what, thousands of options, 30,000. So now I've only got female lifters, right? And so I'll go to my data analysis, I'll go to the regression, I'll go to total weight lifted, my X variable is age, I'll hit OK. So now 0.39, and it's significant at high level, this p-value is basically 0. So it looks like as someone gets older, they actually lift more weight for women. And for males, this was where it was actually a negative effect. Now the p-value here was large, so looks like maybe age isn't a great predictor of strength here, and for men. But for women, it looks like as they get older, they actually potentially have the ability to get stronger. Right? So I don't know, kind of a fun data set to play around with, and kind of a good example of how we can get the results of our original question, but add some content to our projects, and also just kind of add the discussion of whatever the question was by breaking this down into subgroups and saying maybe there's a variation in this effect as well. I did want to look at this. I think, let's see, is it sorted by? You can also, you don't have to like scroll, you can search for things using this bar. No, he's not in it. Who did I think was in it? Let's see. Yeah, I knew him. And then, who else did I know here? I guess my brother's in it. I thought I had, oh, it's because I deleted some of the other stuff that was in there, but he was in one of the data sets I originally downloaded before I made it smaller. But anyways, so this is kind of just how you start with the original raw data and break it down to run your regressions. Now, obviously here I didn't have as many control variables, and some of you for your projects, I didn't have a lot of control variables I could give you. But if you do have them, like where was it here, try to include as many control variables as you can, right? It just helps eliminate some of the bias that could exist. Okay. So hopefully seeing me we're kind of walking through that example helps. Like I said, I think everyone's got data. So if I look at this folder, right, everyone, this is all the work I did to get you guys all your data. Everyone should have something, and should be ready to go. Look at, someone asked me about it, and I mentioned this very early on in the class. There's a projects components that kind of explains what you need in each one. There's no set length requirement, but you should have. I would say it'd be hard to write something that was shorter than 4 or 5. I don't know, 4 pages probably minimum to really satisfy everything. Especially, I say at 4 or 5 pages, but you can also put like in your regression results or different tables, summarizing the data, kind of describing the data will take up some room. So I think it's not hard to get a 4 or 5 page paper out of this pretty easily, especially when you're putting in kind of those results from your regression output. If you have any questions, please contact me. I've been doing WebEx or Zoom or whatever people want to do meetings, and so we can do that, and I can help you with the screen share since I also have your data sets. We can kind of walk through it together, and I can help you get some of the regressions ran if you're having difficulties with them. Okay. All right. I will likely, like I said, post another short lecture. I'm not sure exactly when it's going to be this week. Things are a little bit crazy for me right now, but I will try to get one recorded that is a little bit more review of some of the types of problems that you could see on the final exam, because we're probably only about 2 weeks now. Yeah, 2 weeks, a couple weeks away from that. So we'll start to do some review for that, reviewing some of the models that I've talked about in previous lectures. All right. that's it for this recording, and I'll get another one up later this week.